Namaskar. Now we'll be finding a inverse of a matrix by elementary operation. Now I have already discussed the properties based on elementary operation, that you can shift a row by a row or a column by a column, or you can add two corresponding rows or subtract over there, or you can multiply by a constant number to get a row over there. Now in this example number 23 of your NCERT, find the inverse of the matrix this. In order to use elementary row operation, by the property of a inverse, can we write down A is equal to I into A? So this A is this 1, 2, 2 minus 1. I'll be writing it as an identity matrix 1, 0, 0, 1, and this A over here. Now when I have written this, so here I can apply a column operation also, or I can apply a row. So this question I have done by a row operation over here. Now what should be your target over here? Your target should be, you have to make on this side, there's the left hand side as a identity matrix. For a identity matrix it should be 1, 0, 0, 1. So first of all here you are supposed to make a 0. Now how to make it as a 0? R2 tends R2 minus twice of R1. If I take 2 from here and subtract double of it from here, so that is 2 minus twice of 1, I'll be getting a 0. That's why I've written this condition. The same condition I'll be using over here, that's a minus 1 minus twice of this, so minus 4, minus 1 minus 4 is minus 5. Now the same operation 1, 0 I'll be writing as it is over here, because I am not putting any operation on the first row. Now 0 minus twice of this, I'll be getting a minus 2. 1 minus twice of this, I'll be getting a 1 over here. Is that clear? Now I am supposed to get here as a 1. So what I have written, R2 tends to minus 1 upon 5 of R2. So when you divide it by minus 5, so you will be getting a 1. And when you divide this 0 by minus 5, you will be getting a 0. The first row I have written as it is. The same operation you will be doing this on this second row also. So you will be getting this elements over here. Now here I am supposed to get a 0, because 1, 0, 1. Now here, according to the identity matrix, this should be a 0. So it means to make it as a 0. So what is the operation I will be using? R1 tends to R1 minus twice of R2. So 2 minus twice of 1, that I will be getting a 1. So it is 1, 0, 0, 1. And here also I will be using the same operation. Now A into A inverse is equal to identity. So value of A inverse is this. So this is your example number 23. Now the same way you are having an example number 24. Now it is a square matrix. The order of this square matrix is what? 3 by 3. Now here again I want to find out the inverse. So by the definition of the inverse, can I write down A is equal to I into A? Here I have written the value of A is equal to I. I means identity matrix, that's of order 3 by 3, and this I have written over here. Now here, according to the definition of the identity matrix, here should be a 1. Now, how to get a 1? So, what I have done, R1 has been taken to R2 and R2 has been taken to R1. Or in simple words, we can say the two rows correspondingly interchange over there. So, I have taken this row R2 at R1, so I am getting a 1, 2, 3, 0, 1, 2 I have taken at the second, and rest of the thing, there's a third row I have written as it is. Same thing you will be doing over here. Whatever the operation you are applying, it should be applied on both the sides over here. There's the left hand side and the right hand side. Now after getting this, the second operation I have applied, R3 minus thrice of R1. R3 tends to R3 minus thrice of R1. Here it is 3 minus 3 times of it, you will be getting a 0. Here it is 1 minus 3 times of this, so minus 5. Here it is 1 minus 3 times, so minus 8. The same operation you will be applying over here. 0 minus 3 times of 0 is 0. 0 minus 3 times is minus 3. 1 minus 3 times of 0 is 1. So you are getting this. Now after getting this, now coming to the next step of this. After getting this, so you are getting a 1, 2, 3, 0, 1, 2, and the third row you are getting a 0, minus 5, minus 8, and this you are getting. Now what operation I am using here? That's the R3 tends to R3 plus 5 R2. So what is R3 here? 0 plus 5 times of R2. So 0 plus 5 times of 0, I'll be getting a 0 over here. The same way you can do with this second element, third element also. So you'll be able to get a 0 and a 2. The same thing has to be done on a RHS. Remember this thing, whatever the operation you are applying, that has to be done on both the sides of this equation. Next operation I am applying, R2 tends to R2 minus R3. So R2 is this and R3 is this. The first row I'll be writing as it is. Now R2 minus R3, 0 minus 0, that is 0. 1 minus 0, that is 1. And 2 minus 2, that is 0. And the third row I have written as it is. The same operation will be applied on the right hand side also with respect to the second row. The first row you'll be writing as it is and the third row you'll be writing as it is. Okay. After getting this, now what I am supposed to get over here? 0. So to get a 0 here, if I take this element and minus twice of this, I'll be able to get a 0. So what operation I am using? R1 minus 2 R2. So here you'll be getting a R1 minus R1 tends to R1 minus twice of R2. So 1 minus twice of this, you'll be getting a 1. 2 minus twice of this, you'll be getting a 0. 3 minus twice of this, you'll be getting a 3 here. The second row, third row I have written as it is. The same operation has to be applied on this first row over here with respect to this. After using this, now what you are supposed to get? Here you are supposed to get a 1. Now how to get a 1? If you divide the every element of row R3 by 2, so 0 by 2 0, 0 by 2 0, 2 by 2 that is 1 over here. The same operation has to be applied on the third row on this side also. After getting this, now what is left here? 3. Here you are supposed to get a 0. So what I have done, R1 is this minus 3 times of this. So I'll be getting a 0. The same thing has to be done with the element A12 and A11 also. And the same operation has to be done in the right hand side also. Now when you have done all these calculations, now remember one thing, you can change this order also. The operation that I am using here, you can do this operations, your corresponding operations according to the requirement with respect to the column also. After getting this, now when we get a identity matrix in the left hand side, so we know the property that the matrix A into its inverse will be always equal to I. So it means this is the value of A inverse. So A inverse is 1 by 2 minus half 1 by 2 minus 4 3 minus 1, and this is 5 by 2 minus 3 by 2, and this is half. So this is the inverse of a matrix A. Thank you so much.